So what do you notice? What do you wonder on these? What if you solved them all? So how do we go about solving the first one? X equals positive and negative 2, right? Okay. What if we solve the next one? What will we get? X equals 2i, right? Because we got that negative underneath that radical. What about the next one? Well, on this one, we can set these equal to 0, and we can solve. And this last one, we would solve, and it would just give us a positive 2. All right, so what do you notice for all of these? They all have what in common? A 2. Okay, either positive or negative or imaginary. Okay. On solving radical equations. Okay. So describe the steps taken to solve the equation, then check the solution to see if it's valid. If it's not a valid solution, explain why. So what happened between here to here? What did they do? So from here, there was a 4 on this side, and then there was a 10. There was a 6 on this side. The 6 isn't there. What did they do with the 6? They added the 6. Good. Okay. From here to here, what did they do? They squared both sides. And then they got the answer, right? Now, they always say to check the solution, okay? Or with radicals, they're going to say that. So what you want to do when you check the solution, you're going to write down the exact same problem. But instead of writing X, you're going to erase it and write whatever number you're checking for. Okay, so when we check, it's like when your teacher in middle school told you to plug back in. It's like when your teacher in Algebra 1 told you to plug back in. So now we're going to check that work. So what's the square root of 100? 10. And 10 minus 6 is, okay, is 4 equal to 4? Yeah. So then x equals 100 is a correct answer. All right, what did they do from here to here? Or added the 6. What did they do from here to here? Cubed both sides. And then that final step is the answer, right? So now we're going to check our work. We're going to rewrite the original expression. And we're going to write, instead of that x, we're going to write 1,000. Now, what's the cubic root of 1,000? 10. Okay, and if you're not sure with that kind of stuff, you can plug it into Desmos and I'll do it for you. 10 minus 6 is what? 4. Is 4 equal to 4? Yes. So this is our answer. If we got any other number on this other side, like if these two parts were not equal to each other, this would not be an answer. But since they are equivalent, then x would be our answer. So looking at this first problem, what's the first thing I'm going to do? What was the first thing that we did on the last two problems? We moved the 6, right? Okay. In this case, 6 is positive. So if we're going to move that guy to the other side, we're going to subtract 6 from both sides. We're going to bring down that square root of x. And 4 minus 6 is negative 2. Now, if we want x by itself, we're going to square both sides. And notice how I put that guy in parentheses. And that's going to give us x equals 4. Okay. So now we're going to check our work by rewriting the exact same original equation. And instead of writing x, we're going to write whatever number we just solved for. So 4. So what's the square root of 4? 2. 2 plus 6 would give me what? All right, is 8 equal to 4? No. So this would not be a valid solution. So in this instance, we're going to say it has no solution. Okay, on the next one, what are you going to do with this 6? Subtract it. So this is going to give me the cubic root of x equals -2. Now we want x by itself, so we're going to cube both sides. Notice how I put parentheses around that guy. This will give me x equals and -8. When we check, we're going to take -8 and plug it in. So that's going to give me the cubic root of -8 plus 6. We know that the cubic root of -8 is going to give us -2. -2 plus 6 gives me 4. And 4 does equal 4. So x equals -8 is our solution. Okay, one common mistake that people make is when they check their work, they say that this is the answer when that's not the case. Okay. So please make sure that when you check your work, it's whatever you plugged in that is your answer, not the checked work. Okay. And just be careful because they like to plug those in as the answers. Like they like to say, hey, this checked work, so x would equal 4, and that's not the case. Okay. We're going to do something very, very similar. Okay. So what's the first thing we're going to move over? The 5. So we're going to subtract 5 from both sides. And so that's going to give me the square root of 2x plus 1. 2 minus 5 is going to give us -3. So all I've done so far is move the 5 over. Now, we're trying to get x by itself, but it's trapped underneath that square root. So we're going to square both sides. And so that's going to give me 2x plus 1 equals, and this is going to be +9. Many times people don't multiply -3 times -3. Be careful of those signs. We're now going to solve for x. So we're going to subtract 1. And we're going to divide by 2. So x is going to equal 4. Take a moment after you finish writing that down. I want you to check your work and see if it's a valid solution. Work. Okay, so again, you're going to rewrite this exactly how it is. Yep. Okay, so we're going to we're going to plug in, instead of that x, we're going to put 4. And so now we're going to simplify. 2 times 4 is going to give us 8. 8 plus 1 is going to give us 9. The square root of, positive square root of 9 is going to give us positive 3. And 3 plus 5 is going to give us 8. It's not the same, so it's going to be not a valid solution. So we're going to say no solution. Okay. This next one's a little funny. You see this sometimes. If there's a radical on one side and a radical on the other, and there's like kind of like nothing else written there, what you can do is you kind of drop the radical and then you can solve from there. So for instance, we're going to have 2 times 5x plus 3 equals 3x plus 7. So we're just going to drop the radical. Now, the only thing is, technically, when we are dropping the radical, we're technically squaring it. So if we're going to square this, we also have to square the number that's outside. So 2 squared is going to be what? 4. Okay, so again, dropping that radical is the same thing as squaring it. Okay. All right, now we're going to distribute that 4 and we'll solve. So we'll get 20x plus 12 equals 3x plus 7. Okay, so now we're going to move that 3x to the other side. And so that's going to give us 17x plus 12 equals 7. I'm going to move that 12 to the other side. I know, it's a lot. And that's going to give me 17x equals negative 5. And then we're going to divide by 17. And we're just going to leave this as a fraction. So we're going to say x equals negative 5/17. Problem is, we got to check that mess. And I'm going to show you a quick way to do that in just a second. Okay, so what we're going to do is rewrite the exact problem. And instead of the x's, we're going to write negative 5/17. Okay, so we're going to erase the x's and we're going to write negative 5/17. Negative 5/13. Okay, I'm going to be honest with you. I don't want to simplify that, and that's a lot of fractions. So I'm going to go into Desmos and type this madness in. So Desmos to the rescue. Okay, so what you're going to do on this is you're going to type the left hand on one row and then type the right hand on the next row. So I'm going to type it exactly how it's written. Negative 5/17. And then plus. Okay, and I'm trying to see if the other side is equal to that. So 3 times negative 5/17 plus 7. Yes. So you see that both of these are equal to each other. Okay, the decimals are the same. Okay, please don't type all of this in one row because it won't give you an answer. Okay, so you type 1/2 and then the other half. So yes, it does work. So negative 5/17 would be our answer. There we go. So yes, it works. X equals negative 5/17. Okay. That Tyler made. What error did Tyler make? Okay, so what did he do from here to here? Okay, so he squared. Is that right? Yeah. Okay, so from here to here, what did he do? Okay, so what did Tyler do wrong? He didn't check. He didn't check. So we got to take 22 and we got to plug it back in here. So 22 plus 3. 22 plus 3 is, and if it's nothing is written out here, we assume it's positive. So what's the square root of 25? Is 5 equal to -5? No. So not a valid solution, and there would be no solution on that. Tyler done messed up. Okay, so what did she realize on this? Well, she can go ahead and give an answer because one side is positive and the other side is already negative. And can a positive ever equal a negative? No. So the answer would be no solution. And she didn't even have to do any work. Okay, now this only really works if you don't have anything to add to the other side, because sometimes that changes this number to be positive. So, but if it's just the square root and it's set it equal to a negative number, then it's going to be no solution. All right. Okay, so we're going to solve for x on this one. All right. You see how there's a negative in between these two radicals. It's almost like you're adding like x plus 3 type deal. Okay. You can move that 3 to the other side, and just like that, we can also move this square root of x plus 6 to the other side. So we're going to add that to the other side. So this is going to give us square root of 2x minus 5 is equal to square root of x plus 6. So all we've done is move this radical to the other side. Now we've got radical equals another radical. So you can drop the radicals by squaring both sides. And that's going to give us 2x minus 5 equals x plus 6. So we essentially squared both sides and got this. Now we're just going to solve like we normally do by moving your x's to one side, numbers to the other. So we're going to subtract x. Add 5. And divide by 2. And whoever keeps giving you answers in fraction form is the worst. Once we solve for a number, what are we going to do? Got to check it, because that makes the difference between it being an answer and having no solutions. Okay, so go ahead and take a moment, check that work. Okay, so we're going to plug this into Desmos to check it, because I'm not doing this in my head. All right, so if we got square root of 2 times 11 divided by 2 minus 5, and we're going to say minus the square root of 11 divided by 2 plus 6. So is that equal to, I think it was 0 on the other side? Is that equal to 0? No. It might be close, but it's not the exact, right? So this would be no solution. Okay. All right, this next one is the one that you're going to see most often. Okay, so here's what you're going to do. You've got one side that has a square root and one side that does not. Okay, so with that being said, you are going to square both sides. And what happens there is now you're going to take 3x plus 5 and multiply it times 3x plus 5. If I take a square root and I square it, that just drops the square. I'll give you a second to catch up. All right, so we're going to multiply this out. We got 3x times 3x, that's going to give us 9x squared. 3x times 5 is going to give us 15x. 5 times 3x is going to give us 15x. And 5 times 5 is going to give us 25. And then I'm going to keep this guy the same over here. Now, what you're going to do is move everything to one side. So we're going to have, we can combine like terms first. We know that 15 plus 15 would give us 30. So we can go ahead and rewrite that. But we're going to move everything to one side in order to solve. So we're going to subtract that 6x squared and put it over here. We're going to subtract 19x, put it over here. We're going to subtract the 29 and put it over here. So these would all cancel. And I would end up with 3x squared plus 11 minus 4. You could factor this now. Let's say you ain't that good at factoring. Okay. What I'm going to tell you to do is you're going to graph it, see where it crosses the x-axis. Okay. If you want to factor this, you would do a times c, which is negative 12. B is 11. What two numbers can I multiply together to get me negative 12, but add together to get me 11? That's going to be 12 and negative 1. So this would be, and then we have a is 3. So we're going to divide by 3. So that's going to give me x plus 4 and 3x minus 1. When we solve, that would be x equals negative 4 and x equals 1/3. Now, when you graph it, though, okay, now when you graph it, though, it's going to tell you that answer. So when I come in here and I graph this equation down here at the bottom, okay, so I'm going to hit clear really quick and I'll come back. Notice how it crosses at negative 4 and it crosses at 1/3 or 0.33. Okay, that way I don't have to do a bunch of math. But what you do have to do is plug in both of those things back into the original problem. Okay, so coming back in here. Okay, guess we're not going back. There we go. Okay, so coming in here, we're going to take negative 4 and we're going to plug it in for all of our x's. We're going to take 1/3 and plug it in for all of our x's. And we're trying to see if both of them work, one of them work, or none of them work. Okay, so I'm going to give you a second to finish writing that down, and then we'll check it in just a second. Now we're going to check our work. So we're going into Desmos, and we're going to type it exactly how it is. But instead of writing the x's, we're going to write negative 4. Okay, so that's the left-hand side. The right-hand side. Thank you. We see that these are not equivalent. So negative 4 would not work. Okay, and what was our other solution? 1/3. So we're going to plug 1/3 in. Those are equal to each other. So we would have 1/3 as an answer. So coming back in here, we would have x equals 1/3 as our final answer. Okay, so Desmos definitely is going to be your friend when it comes to this stuff. Sometimes you might run into something like this, where it gives you like some equation. You've actually seen this distance formula back in like geometry, right? Like it's been a long time since you've seen it, but you have seen it. Let's say that you're going to solve for x sub 2. That means that you're going to try to get this guy by itself. Okay, so what we're going to do is we're going to write out the distance formula as is. So D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And we're trying to get this by itself. But this is underneath this radical. So what do we do to get rid of the radical? Square both sides. So this is going to give me D squared equals, this now drops the radical. So this is going to give me x2 minus x1 squared plus y2 minus y1 squared. Now we still want x2 by itself. It's attached to this y junk over here. In order to get rid of that, we can move that to the other side. Okay, so we're going to subtract that whole thing and move that guy to the other side. So now we have D squared minus y sub 2 minus y sub 1 squared equals x sub 2 minus x sub 1 squared. Now we still want x sub 2 by itself, but it's attached to this squared. In order to get rid of a squared, what do you need to do? Take the square root. Okay, so we're going to take the square root of both sides. When we do that, we get the square root of D squared minus y sub 2 minus y sub 1 squared equals x sub 2 minus x sub 1. Now we still want x sub 2 by itself, but it's attached to this negative x sub 1. So we're going to move that x sub 1 to the other side by adding. So we're going to get D squared minus y sub 2 minus y sub 1 squared plus x sub 1 equals x sub 2. You want to know. This is the problem you want to know because you're going to see this on your test. I'm telling you right now, you're going to see this one on this highlight star circle, whatever you do. You're going to see this guy and you'll probably see something very similar to this. So this is moving around variables. I know we get a little bit tripped up by variables. Remember, variables are just numbers that haven't been assigned yet. Okay. So in physics, because I know y'all love physics, you got kinetic energy equals 1/2 mv squared. Y'all probably seen that before. It represents the kinetic energy for one molecule. Solve this equation for velocity. Okay, so which one of these variables is velocity? V. Okay, so we got kinetic energy equals 1/2 mv squared. So we want V by itself. What's it attached to? M and 1/2, right? So we want to get rid of that. So we're going to we're going to divide both sides by M. And so that's going to give us kinetic energy divided by M equals 1/2 V squared. How do we get rid of this 1/2? Times what? Times by 2, right? So we could divide by 1/2 or multiply by 2. I'm going to multiply by 2. And so that's going to give me 2 kinetic energy divided by M equals V squared. Well, V is attached to the squared. How do we get rid of a squared? How do we get rid of a squared? We take the square root, okay? And so you get V equals the square root of 2 kinetic energy divided by M. Fun fact, if you looked at your physics like formula sheet, I'm sure you would probably find this as an answer or this as a formula. Yeah. All right. So using the equation above, scientists derive the root mean square root, RMS, velocity of a gas molecule to be this. Solve this equation for mass. Okay, let me be honest with you. They're going to write out a really long paragraph to try to confuse you. all you really need to focus in on is what are they asking for you to solve. Okay, so you're looking for the verb that, or the action word that they want you to do. They want you to solve this guy. So they want you to get m by itself, right? Okay, but m's in the denominator and m is underneath the square root. So the first thing we're going to do is we're going to remove the square root. How do we remove the square root? Squaring it. Fantastic. So that's going to give me u squared equals 3RT divided by m. Now we want m out of the denominator and we want him by himself. So we're going to multiply by m to get him out of the denominator. And we're going to do it on both sides, because if you do it on one side, you got to do it on the other. So this is going to give us, I'm going to draw a little arrow right here. U squared times m equals 3RT. But now, is m by itself? No, it's attached to u squared. Well, how do we get rid of u squared? So divide by u squared on both sides. Those would cancel. And so we would get m equals 3RT divided by u squared. It's almost like rearranging your room. That's how I always feel with these solving equations. You know how like you've moved your bed, you move your dresser, but you can only do it in certain orders? Nope, just me. I was that crazy kid? Okay, thanks guys, appreciate it. So you have to make sure that you do it in the correct order. Like for instance, we had this square root. We squared both sides in order to get rid of that. Okay, I'll give you a second to finish writing. Okay, so let's check your work on this one. Okay, so what's the first thing you're going to do with this guy? We got this x trapped underneath this radical, right? So we're going to square both sides in order to get rid of that radical. Okay, now when we square both sides, this is actually saying x minus 3 times x minus 3 on this left side. On the right-hand side, we have a square root and we squared it. So that's just going to drop the square root. Okay, so now that the x's are all free, okay, we're going to multiply on the left-hand side. So x times x would give me x squared. X times negative 3 is going to give me negative 3x. Negative 3 times x is going to give me negative 3x. And negative 3 times negative 3 is going to give me positive 9. And his right-hand side is just going to stay the same. Is there anything on the left-hand side that I can combine? Yeah. We're going to have x squared minus 6x plus 9 is equal to 30 minus 2x. Now we still want to solve for x. And we have this squared. So we're going to move everything to one side so that we can either factor or graph to see what the solution is. So we're going to move that 2x to the other side. And that's going to give me x squared minus 4x plus 9. And then we're going to move that 30 to the other side by subtracting. So this is going to give me x squared minus 4x minus 21 equals 0. Now, if you wanted to factor this, you could. You would do the big X. You would say a times c is negative 21 and b is negative 4. And so you would ask yourself, what two numbers can I multiply together to get me negative 21, but add together to get me negative 4? And you would tell me negative 7 and 3. So I would have x minus 7, x plus 3. So that would give me answers of x equals 7 and negative 3. If you did not want to factor, you could graph this. Wherever it crosses the x-axis, that's going to be your solutions. Okay? So right now we have these as solutions, right? What do we always have to do with radicals? Check your work. I'm gonna give you a second to check those. Okay, so I'm gonna take 7 and I'm gonna plug it in. So 7 minus 3 is equal to the square root of 30 minus 2 times 7. So when I plug that in, I get 7 minus 3, which is 4. Over here, negative 2 times 7 is going to give me 14. 30 minus 14 is going to give me 16. Square root of 16 is going to give me 4. Is 4 equal to 4? Yes, so x equals 7 works. If I check negative 3, I'm going to plug that in. And remember what we talked about with that last problem? Okay, if you have a negative number on the left-hand side and a positive number on the right-hand side, that's never going to equal. So we can go ahead and say this guy's wrong. Okay, if you want to plug it in and check it, you would get negative 6. And on this side, you would get square root of 36. Square root of 36 is positive 6. And is negative 6 equal to 6? No. So x equals 7 would be our only answer. No. So on January 27th, your first delta math is due. This one is going to be over those exponents and that kind of stuff. Okay. On February 2nd, I think is what I put, there is another delta math that is over this solving. Is the third? Fantastic. That's over solving. Okay. On Friday, this coming Friday, January, what is today? 18th, 19th, 20th? January 20th. You are going to have your first part of your test. It is, it's super short. It's 4 questions. Okay. It is going to be over your exponent rules. Okay. So right now, what I want to do is I want to spend a little time going back over that kind of stuff. But I want you to go ahead and write down these dates so you don't forget. Okay. Yes. That's good. All right. So, first thing, if you have the same base and you're multiplying them, what are you going to do with the exponents? What are you going to do with the exponents? You're going to add the exponents. Okay, so if you have the same base, you're going to add those exponents. Okay, if you have something like this, where you're dividing, what are you going to do with the exponents? Subtract. Okay. If you have something like this, where you would have a power raised to a power, what are you going to do with those exponents? Multiply. Okay. If you have x to the 0 power, what does that equal? 1. Because anything raised to the 0 power is going to equal 1. If you have a negative exponent, what are you going to do? Negative exponents do what to the fraction? Flip the fraction. Okay, now one thing I do want to be careful on is if I have a negative exponent in the top, that means this guy's going to go to the bottom. If I have a negative exponent in the bottom, this guy's going to go to the top. Okay, so watch what happens. I'm going to switch these guys. And then can I simplify this? Yeah. Okay. 3 minus 6 is going to give me what? Negative 3, right? Because 3 minus 6. So that means that guy's still going to be on the bottom. Okay, I'm going to give you, you should be able to work on your delta math at this point. Okay, your delta math goes through all these different types of exponent rules. You need to practice them before Friday. Okay, all it is basically simplifying. One thing though, if you have something like this, where you have x to the third, y to the second, x to the first, which ones can you combine together? Like, what would you do in this instance to simplify? So you would combine that x to the third and x to the first, right? So 3 plus 1 would give me, and I would just keep that y squared chilling out to the side. Okay, you can only combine things that have the same base. If it had any other like variable or number, then you couldn't combine them, right? Okay.